Good day, students. In this clip, we're going to review how to convert polar equations into rectangular form and the reverse, converting rectangular equations into polar form. So, write down the heading for this lesson, review on converting between rectangular, angular, and polar equations, and polar equations. Okay, write this down. All right. Um, so what we're going to be using in these examples is basically the conversion formulas that we used before. Okay, so let's start by doing the following: convert to polar form. Number one, we have x plus y equals 7. Now, the polar form has just r and theta. Okay, one, the other, or both in the polar equation. So we need to get rid of the x and the y's. Conversion formulas, we know that x equals r cosine theta and y equals r sine theta. Okay? So that's what we're going to use to substitute x and y. So for the x, I'm going to replace my x with r cosine theta and my y with r sine theta equals 7. Okay? Substitute these two with these conversion formulas. Now it's customary to have the r's isolated if possible. So let's see, is that possible here? I can factor out an r from these two terms, right? So if I factor out the r, I'll be left with cosine theta plus sine theta equals 7. Now to isolate r finally, I can divide both sides by what I'm multiplying r by, which is cosine theta plus sine theta on the left side, and then cosine theta plus sine theta on the right side. So our final answer is going to be r equals 7 over cosine theta plus sine theta. End of story. Alright? Alright, let's try another example. What if I had number 2, x minus 5 squared plus y squared equals 25. So how do I write this in polar form? So first thing I'll do is expand whatever is expandable and then see if I can set it up for substitution. This can be expanded. X minus 5, 2 copies, plus y squared equals 25. So let's expand these. So you're going to have x squared minus 5x minus 5x plus 25 plus y squared equals 25. Now I can bring the x squared and the y squared together. Combine the x's, you're going to have minus 10x. And then I can subtract 25 from both sides. So subtract 25, subtract 25 equals 0. Now let's see what substitution I can make. I know that for my conversion formulas, r equals r squared equals x squared plus y squared, and that r cosine theta equals x. So let's make the substitutions. X squared and y squared are replaced with r squared minus 10r cosine theta equals 0. Now, is there a common factor I can divide every single term by? I know r goes into 0 and this term and that term. R goes into, I mean, 0 has everything as a common factor. So I can divide r into every single term. And then we'll be left with the equation r minus 10 um, cosine theta equals 0. So we want to get r by itself. So in order to accomplish that, we need to move 10 cosine theta to the other side. So we're going to add 10 cosine theta to both sides. And our answer is going to be r equals 10 cosine theta. End of story. Okay? Alright, let's try another example. Example 3. We're still changing equations into polar form. Example 3. How about if we have x squared minus y squared equals 7. Alright, so how do we do this one? We know our conversion formulas. We know that x is equal to r cosine theta and y is equal to r sine theta. So we're going to make those substitutions in here. So what we're going to have, r cosine theta, quantity squared, substitution for x, minus r sine theta, square, substitution for y equals 7. Now if we expand this, we're going to have r squared cosine squared theta by distributing the square to both of them, and then r squared sine squared theta by distributing the square to both things, and then equals 7. So for this one, let's see, r squared is common on both sides, so let's factor our r squared, and then we're left with cosine squared theta minus sine squared theta equals 7. Now to finish this off, I don't know if you remember what this identity is. If you look at your double angle identity, this could be substituted with something rather nice. The double angle identity I speak of here is cosine 2 theta. So cosine 2 theta, one of the variations of cosine 2 theta is cosine squared theta minus sine squared theta. So we're going to make the substitution, and that's going to give us r squared cosine 2 theta is equal to 7. Okay? Alright, so let's divide both sides by cosine 2 theta. So divide this by cosine 2 theta and divide that by cosine 2 theta. And that leaves us with r squared equals 7 over cosine 2 theta. Now if I reciprocate cosine, cosine goes to the top. What is the reciprocal identity of cosine? Let's see, it's secant, right? Secant anything, secant theta is equal to 1 over cosine theta, right? But in this case, the angle is 2 theta, so r squared is going to be equal 7 secant 2 theta. And that's that. Okay? Alright, now we're going to try another example where we convert an equation into rectangular form. So convert the following equation, example 4, right? R equals 5 secant theta in rectangular form. Alright, so for this one, let's see. We have r equals 5 over secant theta. My substitution formula is there's no secant, right? I know that x is r sine theta. and y is r cosine theta. So I need the parent trig functions. I need either sine or cosine, and this is secant. That's a problem. So let's get rid of that by reciprocating it and replacing it with its reciprocal cousin, which is cosine. Okay? So this becomes r equals 5 over cosine theta. Okay? Now wait a minute. We can put this over 1 and do a cross multiplication. So if we cross multiply, we're going to have r cosine theta equals 5. See, r cosine theta can be substituted with y. So if you take this out, you're going to have y equals 5 and auxiliary. Okay? Alright, let's try one last example and then we can start on the classwork. Let's do example 5. Example 5. What if we have theta equals pi over 3. Alright? So how do we write this in rectangular form? So for this one, what is theta again? Remember, inverse tangent of y over x equals theta, right? So we can replace theta with inverse tangent of y over x. So we're going to have replace theta with inverse tangent of y over x, right, equals pi over 3. So how do we get rid of inverse tangent? What's the opposite of inverse tangent? Tangent, right? So you take the tangent of both sides. You're going to take the tangent, wrong color. You're going to take the tangent of the inverse tangent of y over x. And that on both sides, and on the right side, you're going to take the tangent of pi over 3. Alright, so in this, on the left side, the tangent and inverse tangent cancel out. So you're going to have y over x equals tangent of pi over 3. What is tan of pi over 3? You can use your calculator to figure this out. I'm using my TI-89 because it's much more advanced. So let's see. What is the tangent of pi over 3? Answer? Huh? Uh-oh. Let's change the mode. It's rated. Let's see if that works. Okay, so it's 3. If you use a TI-83, it should give you 1.73205. Let me use the other calculator first and see what it gives us. So, pi over 3 is in radians. Pi over 3 is the same thing as 60 degrees, right? So we can just go tan, okay, we can just go tan 60 degrees. Tan of 60 is equal to 0.3. Okay, let's see the mode. Oh yeah, my mode is wrong. Put in degrees. Tan of 60 degrees is 1.73. So we're gonna have y over x equals 1.7302. I believe that's what we got. 1.732. Alright, and that's that. That's all you need. Okay? Alright. Thanks for paying attention to this clip. Remember, it's uploaded on YouTube for your viewing pleasure. Alright, now I'm going to go ahead and start with the first part of the classwork.